In question 9, a kaon neutral particle decay produce a pion, a muon, and a neutrino. Complete a nuclear equation to show the charge on the particles. So we have to complete this and we have to show the charge on particle. First thing, there should be a conservation of the charge. Because for any decay of the particle or interaction, the charge must be conserved. Kaon is a neutral, so right, if left hand side is neutral, right should be neutral. Anti-electron neutrino does not have any charge, so it is zero. Or anti-muon neutrino, basically it's not an electron neutrino. Muon neutrino also, there is it's antiparticle. The neutrinos are not having any charge. Then what is the charge of the muon? Muon is negatively charged, like electron, muon. They have negative charge, so it will be -1. So if this is neutral, this is -1. So what should be the charge on the pion? The pion should be positive, as there should be a conservation of a charge. Ordinary matter made up of proton, neutron, and electrons. At the time they were discovered, these particles were not thought to be made of any other particle. As you study like about the Dalton atomic theory and then about the nuclear atom. So Dalton atomic theory was considering atom as a fundamental particle, but after that, the nuclear structure atom, we say that atom actually consists of neutron, proton, and electron. And later we found that they are not fundamental, like electrons are fundamental, but proton and neutrons are not fundamental. Explain how proton, neutron, and electron are described in a current standard model of a metal, of a metal. So what are protons? Protons are basically baryons. And what are baryons? First thing, proton are not fundamental. Like when we categorize a particle, they are not fundamental. As they are not fundamental, what we call them as a baryon. And what are baryons? Baryons consist of three quarks. So they are made up of three quarks. Same thing for a neutron. Neutron is also not a fundamental. It is also a baryon and it also consists of three quarks. But what about electron? Electron is a fundamental particle which belongs to a family of leptons, and there is no internal structure, like it does not have any it's a fundamental particle. So fundamental particle means it has no internal structure, like it's a basic particle. You have to learn the standard model and names of different particles as their baryon number, lepton numbers. In question 10, when an X-ray photon interact with the atomic nucleus, a pair production can occur. In a pair production, a photon energy produce an electron and positron. So what is a pair production? Like if there is a photon, the concept is that energy produces a mass here, or energy change to mass. So a photon is there which produce two particles, like which produce one particle and one antiparticle. And example, if it produce electron and then positron. Positron is like positive electron, antiparticle of electron. For this to occur, the wavelength of the X-ray photon must be less than the certain value. What is the maximum wavelength of X-ray photon? Show that the maximum wavelength is about 1 into 10 power minus 12. So how we can work out? First, we will find how much mass we have to produce, because we have to produce the particle and its antiparticle. So we have the formula E is equals to mc square. So what is the total energy we want to produce? Like what should be the total energy of this photon? And from this energy of photon, we'll use the formula hc over lambda. We'll have the energy, we have the Planck constant, speed of light, so we can work out lambda. So E equals mc square. What should be the mass? Because we want to produce electron and we want to produce positron. So the total mass should be the mass of electron plus the mass of positron. C square. Using this formula, what we'll do, we'll get how much energy is needed. And from energy needed, we'll work out the wavelength. State why two electrons cannot be produced by the pair production. So if like here, what we are saying? We are saying electron and positrons are produced. But the question is why two electrons cannot be produced in a pair production. Whenever interaction occurs, there should be a conservation. Like there should be a conservation of mass energy, there should be a conservation of charge, conservation of baryon number, lepton number. So what happened? First, the photon was producing positron and electron. So there was a conservation of the charge because the photon does not have any charge. So the final charge is also +1, -1. So final charge is 0. But if two electrons are produced, so then what is the net charge? Final charge will be -2 because -1 and -1. If the originally it is 0, how a final can be -2? It means it will contradict with the conservation of the charge. So whenever interaction occurs, the charge must be conserved as well. So if initial charge is 0, the final charge should also be 0. So charge should be conserved. Before interaction, the initial charge is 0. So the final should be 0 as well. After production, the positron and the electron move off in different direction. What is the reason for that? Why not in the same direction? So there must be a conservation of momentum as well. So after production, the positron and electron move off in different directions. Suggest what happened to electron and positron after this. So as they're moving in opposite direction, after this, what might happen? First, why they're moving in opposite direction? Like example, if this is a electron, this one is a positron, they're moving in opposite direction. Then after some time, what will happen? There are multiple possibilities. This electron and positron might collide with another atom and transfer the energy, or it might ionize the atom, or there is another possibility that electron, like positron, will meet another electron and annihilate. Annihilate means like when a matter convert into energy, when particle and antiparticle interact, we call that as annihilation. So what will happen? The electrons will interact with atoms, transfer energy. That is one possibility. The second, the positron, what will happen to positron? Positron will interact with another electron and annihilate. So annihilation is a possibility that will happen or occur. Annihilation is there. There's a possibility for, because positron is an antiparticle, and antiparticle, as we have most of the particles on Earth, not antiparticle. Whenever, so positron directly can interact with a particle such as electron and they can annihilate, mix with each other. But what happened to electron? Electron may collide with other atom, may cause ionization, or may transfer its energy. In question 11, which is about the cyclotron, the difference between a cyclotron and a linear particle accelerator. In a cyclotron, we use both electric and magnetic field, but in linear particle accelerator, we use only electric field. And the advantage of a cyclotron, in a small space, we can deflect the particle. So what happened? Same way, when particle is between the D's, the particle does not, it changes the direction. So that is also acceleration, but it does not changes the speed. When it moves between the plates, it accelerates. So between the plates, the black part is representing acceleration. Even in a circular path in physics, when object move in a circular path, that is also acceleration. But this acceleration is not in terms of value or magnitude of speed or velocity. It's in terms of change in direction. So between the plates, between the D's, it does not change the value of this, like it changes the value of the speed, but within the D's, it does not change. That's how the particle is accelerated to a very high speed. Explain how cyclotron accelerate the proton to follow the curved path. So the same, like there are certain points you have to learn for, like as I mentioned previously about the linear particle accelerator or a LINIAC. So same thing for cyclotron, you have to learn. So first, how the particles are accelerated. One mark you will mention, the particles are accelerated by electric field between the D's or in the gap. And the magnetic field is there, which is perpendicular to the direction of the motion of particle, which cause them to deflect or accelerate in a circular path. And the polarities between the D's changes when it reaches the gap again. So the points which you will use to answer a cyclotron. The first point, because I'll write a journal answer, you can change in place of particle, as here we are accelerating electrons. So we'll use, instead of particle, we'll use, or we are accelerating proton. So we'll use proton. But the journal answer, you'll mention the particle accelerate or accelerated by electric fields, by electric field between the D's. The second point you will mention, magnetic field is used to, magnetic field is perpendicular first to motion of the particle or direction of movement of the particle. Which cause circular motion and produce acceleration, but that acceleration is only due to change in direction. Which produce acceleration for circular path. So magnetic field is perpendicular to motion of a particle, which cause circular motion and produce acceleration. That acceleration is due to change in direction. So these are like 3 points, 3 marks. Then electric field or the polarity reverses when the particle reach the D again. Like every time it is in linear particle accelerator, when it reach another tube, it receives the same polarity. it was reversing in between. But in a cyclotron, what happened? Like, say, if this is a proton, so if the proton, we want to accelerate a proton, say this was a proton moving. When it reached this d, this will be negative, this will be positive, this will be negative. So it will accelerate. And then between the d's, it will deflect. When it reach the terminal now changes. So it's like when it complete its cycle, its rotation in one, then terminal changes. It does not change when it is in between. So then it becomes negative and positive. That causes proton to accelerate again. And then due to magnetic field, it will deflect between the Ds. Again, the terminal change. So every time when it reaches between the gap, the terminal changes. Like one D is positive, the other negative, next moment negative and positive. So polarity reverse when particle reach the D again, or the particle reach the gap between the Ds. So this is like 4 points. Then every half cycle, what will happen? The path of the radius will increase as it will have a greater speed or momentum or energy. So as you can see, why the path is changing. So after every half, the speed and the radius will increase. So these are the 5 marks, like the 5 points you should include whenever you're explaining the idea about the cyclotron. In part B, calculate the momentum in Newton second for a proton with a kinetic energy of 20 mega electron volt. Ignore any relativistic effect, means like its mass is not changing. 20 mega electron volt, as I mentioned, energy should always be in joules. So 20 into 10 to the power 6 electron volt, and we have 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So this will be x, we cross multiply. So this will be 20 into 10 to the power 6 multiplied by 1.6 into 10 to the power minus 90. This will give us answer in joules. Now, what is the relation between momentum and kinetic energy? Remember, P square is equals to, if you remember that formula which relate the momentum, so K is equals to P square over 2M. The kinetic energy, EK or KE, is equals to P square divided by 2M. So if I need momentum, it will be under root of the kinetic energy multiplied by 2M. This will give us a momentum. So after getting the energy in joules, don't forget to convert the energy. Like here, it will be 3.2 into 10 to the power minus 12 joules. And this energy, kinetic energy, is there too, where m is a mass of particle. In this case, we have a proton. So that will be 1.6 exponent minus 27. The constants will be given, like mass of proton, mass of electron, mass of neutron. These constants will be there. So cyclotron is there, Trev. Cyclotron can produce a beam of proton of different energy. This can be done by extracting a proton at different distances from center of a cyclotron. Like we can take the electron from different parts, so it will give us different speeds of the proton and different kinetic energy will be there. Calculate the radius used to extract a proton which is having a kinetic energy of 20 mega electron volt. The magnetic flux is given. So to work out the radius, here we already have the momentum. Like the previous we work out the momentum. And we can, because what happened, the centripetal force is equals to magnetic force. The centripetal force is mv square over r, and magnetic force is v is equals to, the F is equals to qvb. Q is the charge, v is the speed, and b. So when we simplify this v square will cancel with v. So this is mv. mv is the momentum which we already worked out in the previous part. So I can say p r is equals to qb. So if I need radius r, so it will be p divided by qb is equals to r. So we have the momentum from previous part, we have the charge which is constant, we have the strength of a magnetic field, so we can work out the radius. So you don't have to show this working. If you in exam you write this formula directly, like this is also a formula that momentum divided by qb is equals to r. This is a formula we normally use when object move in a circular path to determine the radius of a circular path. Next, the beam of a proton can be used to probe the structure of matter. Determine whether the wavelength of 20 mega electron volt proton is suitable to investigate a nucleus of a diameter 1.3. So if you want to investigate, basically to investigate the lambda, the wavelength should be equal to gap size. Like we will compare the wavelength with the size, we have the radius, but we'll compare with the, because